Okay, so we want to take a look at what each square on the periodic table can tell us. Okay, the first thing that it can tell us is what's the actual name of the element. Okay, so this one is sodium, and it's also got a chemical symbol or a element symbol. Okay, and that element symbol always has a capital letter to start with, and if it has two letters, the second one will always be small. Now, the other thing that it can tell us is up here we have what's called the atomic number. The atomic number tells us the number of protons. This one has 11. Now, the other number over here, which you'll notice that has a decimal, this is called the atomic mass. And the atomic mass is the average mass. It's the average mass of all the isotopes or varieties of that element. Some elements can have many different types of isotopes, and so it's an average of all those together. Well, sometimes you might confuse which number is which. Like for this one, is this the atomic number or is it the atomic mass? Well, you can think of this number is always going to be a whole number, because you can't have just a part of a proton. You're going to have a whole number for that. This number here, the atomic mass, is an average, so it makes more sense that that one is a decimal. So the atomic mass is the average mass of all the isotopes or variations of the atom for that element. So for example, sodium has 11 protons, but it's got an atomic mass of 22.99. And the reason for that is because it's an average. It's an average mass of all the isotopes. Some types of sodium can have a different weight or a different mass. It might have 21, 23, 24, 26, or 28. All these are different possibilities of the same type of element. Okay? If it has 11 protons, it's always going to be sodium, but it can have a different weight, and we call those isotopes. So an isotope is a variation of an atom that has gained or lost neutrons, resulting in a different mass. So if I were to take the average of all of these, I would get the atomic mass. So these are just different varieties or different types of sodium. So one of the essential questions that we want to be able to answer is, what can we differentiate between the atomic mass and what's called the mass number? The atomic mass, remember, is the average of all the isotopes for that atom. So this is the atomic mass for sodium. Now the mass number, because we might be looking at sodium that's got a mass of 28 or 24, the mass number is the total mass of particles found in one specific atom or isotope of an element. So this number is not found on the periodic table, because on the periodic table it tells us the average of all those isotopes. So this can be determined by observation, by looking at the nucleus and seeing how many protons and neutrons it has. When we are dealing with problems, I will tell you what the mass number is so you can figure out the problem. So in our problems, we'll be dealing with neutrally charged atoms. So a neutrally charged atom means that it has no charge. Okay, it's not positive and it's not negative. So in a neutrally charged atom, the number of electrons must be equal to the number of protons. Remember, electrons are our negatives and our protons are the positives. So you got to have the same number of positives as negatives to equal no charge. So since positive has to be the same number as negative to equal 0. So however many protons we have the same number of electrons. So in this problem, it says how many protons do we have? Well, we look at the atomic number to determine the number of protons, and that is right there given to us, 11. So if we have 11 protons, therefore we automatically know that we have 11 electrons as well. So going forward, we can determine the number of protons and electrons by looking at the atomic number. But what's left? We need to know how many neutrons there are. So in order to figure that out, we got to do a little bit of calculation. Okay, and it's a pretty simple idea. We take the mass number and we subtract the atomic number, and that will give us the number of neutrons. So in this example, we have a mass number of 24. This sodium atom has a mass of 24. And we're going to subtract the atomic number, which is 11. And that should equal our number of neutrons. Okay, so let's try a couple examples here. So using oxygen as our example, let's find the number of protons, neutrons, and electrons. So it's easiest to start with the atomic number, which tells us the number of protons. And in this example, we have 8. Now, to find the number of neutrons, we need to take the mass number, which is given to us, and we subtract the atomic number, and that will give us our number of neutrons. So for this specific type of oxygen, it's got 10 neutrons. Now the number of electrons is easy because we know that in a neutrally charged atom, the positives or protons have to equal the negative electrons in order to have no charge. So we know that these two are going to be the same. So if we were going to make a diagram of this, we would have in the nucleus 8 protons, 10 neutrons, and orbiting around that nucleus would be 8 electrons. Let's look at another example of calcium. So calcium has an atomic number of 20. The atomic number tells us automatically the number of protons. To figure out the neutrons, we need to know the mass number. So in this example, this type of calcium, this isotope of calcium, has a mass number of 40. So we're going to use that mass number, and we're going to subtract the atomic number, and that will give us the number of neutrons. So this isotope has 20 neutrons. Now, if we remember that the neutrally charged atom, the positives have to equal the negatives, so the protons have to equal the electrons. We're going to have 20 of those as well. So going back to our essential questions, we need to be able to draw a diagram showing the structure of an atom and be able to label the particles, location, and charge. We also need to be able to differentiate between atomic mass and the mass number, so what it is and where you find it. Can you do that? If you can't, you might have to go back and relook at some of these problems again.